Hello, I'm Harry Glorikian, and this is the Harry Glorikian Show, where we explore how technology is changing everything we know about healthcare. I've been saying for years that it's time to stop thinking of AI as a fantasy that's far removed from our everyday lives. And since November of 2022, when OpenAI released ChatGPT and put the power of large language models into the hands of everyday consumers, we've been seeing how true that is. Large language models and the applications and interfaces being built around them are already changing the business of search. But it goes way beyond that. This new form of AI is also changing the way software companies write code and the way biotech companies screen for new drug candidates. And now they're about to change the practice of medicine. My guest today, Vivek Natarajan and Shek Azizi, are both researchers on the health AI team at Google. I wanted to have them on the show because Google, as much as any other company, is pushing the boundaries of what large language models can achieve in specialized domains like health and medicine. This spring, Google announced it would start rolling out a new large language model called MedPaLM-2 that's designed to answer medical questions with high accuracy. How accurate? Well, when Google gave MedPaLM-2 the U.S. medical license exam, which is the test all doctors have to take before they're allowed to practice, it scored 85%, which is in the expert range. To create MedPaLM-2, Google started with a general large language model called PaLM, then fine-tuned it using data and feedback from actual clinicians. But the interesting thing, according to Vivek, is that Google didn't have to feed a lot of extra training data into MedPaLM-2 to make it smart about medicine. Its ability to answer medical questions came almost for free, in his words, because PaLM itself was trained on such a large body of data from the internet. Vivek says, quote, "When you start accumulating data trawled from all these different sources, it invariably contains the information you need," unquote. What PaLM, ChatGPT, Bard, Bing, and all the other new large language models have in common is that they're all trained on hundreds of billions and possibly trillions of data points, which gives them the ability to scan and remix almost the entirety of human knowledge. In medicine in particular, it seems clear that consulting with AI is going to become an indispensable part of every medical journey. Whether you're a patient searching for information about your symptoms, or a doctor looking for an expert second opinion, or a drug developer looking to prevent the next pandemic. That's a trend I could already see coming 3 years ago when I wrote my book, The Future You. But we're still just starting to feel its impact. And now that it's almost here, the world Vivek and Shek are helping to create at Google feels both exciting and a little bit scary. But without further ado, let's dive into the interview. Shek, Vivek, it's great to have you both on the show. I've been really looking forward to this discussion and sort of diving deep into this area. So it's great to have you guys here.
Yeah,
glad to be here.
So before we jump into the meat and talking about MedPaLM-2, for say the non-technical people in the audience or those people who don't follow the news about AI or read about it every 20 minutes like I do, can you guys start out with say a brief description of the underlying large language models like PaLM or PaLM-2?
Okay, so I can start and Shek, feel free to jump in. So the key idea behind some of these large language models, I like to think about this in 3 ways. So the concept of language models that can predict the probability distribution of sequences has been around for a long period of time. I think it might even go back to the 1970s, and we've had different iterations or different techniques of how to build out these language models, and different kinds of applications ranging from speech recognition to like machine translation systems. I would say the predominant idea, even like as recent as 2015, 2016, was these n-gram language models, where you basically have a very large corpus of text. Like sometimes it could even be like trillions of tokens, and then you basically go through those sequences and then measure these counts and use those counts to estimate probabilities of sequences. So that was kind of an idea that worked reasonably for like, when you had these short context lengths, but then as soon as you wanted to like model text over longer sequences, it was kind of starting to fail and break. So but then what happened was around 2017. I mean, we know this, like this breakthrough with transformers, and then transformers have been shown to work across a bunch of different applications since then. And the key ideas were first demonstrated in machine translation, but then language modeling emerged as this breakthrough application. And then again, there are different variants of transformers that I'm not going to go through it, but like the one big one that I think like was with like we came across that one with the advent of GPT-3 was this decoder only transformer models. And the GPT-3 paper basically showed three different ideas. One was using a decoder only transformer model. Second was training this transformer model on a very giant corpus of text. So like internet scale text. And so what the model does is like the objective itself is kind of very simple, where you're basically trying to predict the like download a bunch of data from the internet and then predict the next sequence of words from it. So it seems very simple at a high level, but then if you look under the hood and if you want to do this really, really well at scale, at internet scale, then the model has to, like, for example, it not only needs to like understand syntax, but also semantics, and also develop like basic understandings of different topics or subjects that we might encounter on the internet. So it could be physics, chemistry, biology, and in our case, it's medicine. And so transformer models, decoder only transformer models on internet scale data. And then the third thing is alignment strategies. And so that wasn't explicitly part of the GPT-3 paper, but since then, like people have shown within like a few different models, InstaGPT, ChatGPT, etc., where you can not only train these models to do well on these language modeling tasks, but you can also control their behavior and ensure that their outputs are safe and aligned and fun. And so I think that has been the key breakthrough, because there have been previous iterations of language models. I think some people would remember Microsoft A, which was like released on Twitter like back in, I think, 2015, 2016, but then kind of like went crazy in a day or two and had to be taken out. But like ChatGPT has been around for months, GPT-4 has been around for a couple of months, and people are basically, and BART has also been around. And while these models do make errors, people relate to it better, it's not going crazy, and more often than not, people are just delighted. And so I think these three breakthroughs in transformers, breakthroughs on decoder-only transformers, which allow training at internet scale data, and then the third one is alignment strategies. I think that is what has led to models like GPT-4 and PaLM-2.
So around the time of Google I/O, you guys released a video, which Vivek, I think you were in it. So where you stated like that medical question answering has been a research grand challenge for like several decades. And I think that phrase, medical question answering, has a very specific meaning in the worlds of AI and medical informatics. So I'm wondering if you could sort of unpack that a little for me. For, what forms of or has medical question answering technology taken over the decades? It was interesting because when I heard it first, I was like, I'm not very familiar with that particular term.
I can take this. So to put it in like a simple word, is like question answering, as we are like dealing with like in daily basis, but for medical purpose. And it can range from like different type of questions that they have medical context. For example, when you're going to your doctor, you're asking some question, you have some concern, and you're forming that concern in a form of a question. You can ask that question from like a search engine and going from there. So those type of questions, for example, you can say that I have headache. What's medicine that I need to take to cure my headache, or do I need to see doctor for this type of headache that I have? These are some sort of like medical question answering that we are like dealing with. But one form that it's been like a grand challenge for long was that US medical licensing exam questions that's been like around for long. And those sort of questions that they are for professionals. And when doctors wants to pass their medical exam, they're going through a multiple round of like exam and question asking. So um, uh, the first round, the USMLE exam, it has been like a challenge for long. And the reason was that we are dealing with a lot of like reasoning that language models need to provide, and retrieval of like different kind of like information and piecing them together to make a conclusion and like provide an answer that is like grounded and valid and not biased. So that's been around for like multiple decades, like around 3 decades. And most of the performance that we had like from previous methods was around like 50%, cap at 50%. And with the introduction of like MedPalm model, we, for the first time, basically passed the exam like passing mark, which is like 60% correct answer. And that was like a really groundbreaking like moment for us. And we see that, okay, we can reach areas that we can like retrieve information in like a safe fashion and like answer this question, provide answer that they are not biased and like they are grounded. So if you want to add anything, Vivek.
No, it's well. So I want to step back so understand sort of how and why did you guys decide, hey, let's make a specialized version of medical, version of Palm. I'm assuming that somebody had a hypothesis that Palm might be actually good at medical question answering, and especially if you tune that version to specifically do that. And I'm assuming, MedPaLM-2, which you guys released, I believe, last week, if I remember the timing correctly, it's a result of that experiment. So was that always in the plan?
Yeah, so I can take this one on. So at Google has always been at the forefront of large language models. Transformers were invented at Google, and we've since then had various versions, BERT and Palm and everything. And we know that these models, generally looking at their performance on various natural language understanding benchmarks, that these models at scale with large enough number of parameters start not only encoding knowledge that that is used to train them, but also do have like reasoning capabilities. So there is that substrate of, if I may use that word, like an intelligent agent in there. But so that's so you can argue whether that AI is similar to human AI or not. But in terms of specialization, like even when we humans have like basic learning capabilities, like learning and adapting to new situations and environments, right? But then if you want to do something like medicine, which is a very specialized topic, you need to like go to school. You need to go to medical school. You need to like understand medical texts. You need to understand everything from the way from molecular biology, medicinal chemistry, all the way up to like clinical outcomes, population health, health equity, and everything. And that requires specialized training that people do for like 10 years. And so you can't imagine a model that has been trained, although it could be a very intelligent model trained on all the internet, to just be out of the box. It could be intelligent about medicine. It could understand certain topics like I do, even though I have no formal training in medicine. But for me to like really go and practice medicine, I need to have that specialized training. And so that is why we wanted to do that. And so this overall project emerged as a brain moonshot, Google brain moonshot that we have at Google. It's basically an umbrella for several people who are keen about a particular topic and decide that thing should exist in the world. They just come together bottom up and then propose it and work on it. And so this project came through in that way. And then the tagline for that project was sending these foundation models and LLMs to medical school. And so the idea was to train these models on data that you would typically see in medical school, like medical books, literature, everything, and then allow them to absorb that knowledge, learn from expert demonstrations, and then also like maybe put them in real world settings where they can actually learn from real world interactions. And so that's the specialization step. And we believe you need that step. So even if you have like a very powerful general purpose large language model, like if you don't have this expert specialization step, we don't think those models are ready for use in the medical domain yet. And in the MedPalm paper, we showed that, right? And so we took the out of the box model, which was PlanPalm, and that was state of the art on many of these natural language processing benchmarks. But then as soon as we started doing more rigorous evaluation with like clinicians, even with lay people, big gaps emerged between the PlanPalm model and then responses from like expert physicians. But then we also showed that if you do like alignment, and we have some very data and computer efficient techniques to do that, which we showcased in the paper, you can very quickly start bridging this gap. And so that's what we showed in the MedPalm paper, that specialization step, that fine tuning step, that alignment step is extremely critical. And that you don't necessarily see the value of that when you're like, evaluating on these USMLE style benchmarks, but the value of that becomes more apparent when you are doing this rigorous human evaluation that tries to mimic real world clinical applications and workflows. And since then, in the MedPalm-2 paper, which is going to come out very soon, we'll be taking that to the next level, doing even more rigorous studies.
Yeah, I'll be looking forward to that to the next paper, because I'm trying to keep up with. I feel like there's not enough hours in the day, and I don't know if I should just give up sleep to keep up with the rate of change. But it's funny, you're using words like reasoning and so forth, and I'm always trying to pull myself back from using words that would be imparted on a human onto a machine, essentially, right? But it's so hard to. So I'm going to use this word as, how smart is, MedPalm-2? I mean, can you share some benchmarks, like how it performed? I know it got a 85% score, which puts it at the expert level. But I guess the question is, just on its own, what does that level of performance mean? Does being able to score well on a licensing exam mean that a model can actually give safe and useful medical advice in a real clinical situation?
I can take this. That's a really important question, and I think this question and like the concern that we have around that was the most valuable part of the MedPalm paper and the work that we are doing. And I think it's a belief that we have that this number on its own and reporting accuracy is not enough. And the reason is that there are multiple other human values that we want to consider before making decision and put this model out there for decision making, or even interaction, user interaction. And this model could be biased, and they could provide, they have hallucination basically, so they can produce answers that they are harmful. And one of the things that we consider in MedPalm paper and MedPalm-2 is that we have a rigorous access of basically performance measurement that we are considering for human evaluation. And these are to consider harmfulness of answers. If there's any bias in the answer, we are measuring the precision of the answer. And if the answer that's provided by the model is aligned with the scientific consensus. So from there, when we have this measurement, we can we have a way to make sure that these answers are actually aligned with the value that we want. And we can guarantee some level of safety for the users to play with them and to use them. And that's natural that when we are pushing accuracy number, definitely precision is improving, but we should be really make sure that alignment is there and the safety is also there.
So you've got MedPalm and you've got MedPalm-2. what is the difference? I mean, maybe in terms of quantities, is it the number of parameters it was trained on, or, or is it just the performance it's having on the medical exam? I mean, I'm sure you guys have made multiple changes to it or trained it further. How did you make the model better, or I'm going to use that word again, smarter?
Yeah, so I would say MedPalm-2 is a combination of three things. So the underlying base LLM in MedPalm was this flan palm model, and then we switched that over to Palm-2, which has been shown to be significantly more stronger on a lot of these natural language benchmarks, on these LLM benchmarks, and so we decided to build on top of that. And then in the MedPalm paper, because we wanted to have like an alignment technique, which was kind of like compute and data efficient, we did not fine tune the entire model. So not all the weights of the model were updated because that model was big, like 540 billion parameters. So it would take a lot of time. And so we did this, we came up with this technique known as instruction prompt tuning, where you have a small set of additional parameters, which we call soft prompt parameters. And then you use expert demonstrations from like clinicians that we have had access to learn these additional prompt parameters using standard gradient descent methods. But what that thing does is essentially it does not impart any net new knowledge to the model. So the knowledge that is already encoded in the weights of this giant 540 billion model already stays there. But what it essentially does is it's like, oh, now you are in this medical domain and there is a lot of knowledge encoded in your weights, but you don't necessarily have to use all of that. So it kind of like shines light to the specific section of, so if you imagine like all the knowledge encoded in this model as like a giant library, and the medical section is like, maybe one specific set of shelves. So this conditioning with these soft prompt parameters is like shining a torch and saying, oh, the answer should be there, look over there. And then the second thing it does is basically it teaches the model the style of this domain. Like the medical domain, when you're giving responses to consumer questions, you need to be more conservative, have a better expression around your uncertainty, maybe shows empathy in your responses depending on the situation. And so from expert demonstrations, we can even teach the model those sort of things. But we haven't done rigorous studies on that front, so I would not be claiming anything over there. But like the key message I wanted to pass on is like instruction prompt tuning is very lightweight, and it does not update the entire model. It just updates the small set of additional parameters. But with MedPalm-2, we decided to do end-to-end fine-tuning. So all the weights of the model were updated with, again, we used, in the paper that we have coming out, we'll detail exactly what data sets we used, and all of them are like public data sets. That helped us like get like further improvements. And then the third thing I would say is this very simple prompting strategy that enabled the model to reason better. So the prompting strategy, we call that ensemble refinement. The idea is you don't want the LLM to produce an answer in a one-shot setting, but rather when it produces an answer, when it considers a question, you want the LLM to produce multiple different answers. And then it can then use those multiple different answers and then collectively weigh the pros and cons of them and then decide to come up with the final answer. So it's kind of like a two-stage process that we come up with. And what we see is that that ensemble refinement strategy enables the LLM to reason better and refine its answers. So I would say it's this combination of three things: switching the base LLM from Palm and Flan Palm to Palm-2, end-to-end fine-tuning, updating all the weights of the model, and then this new prompting strategy that enabled us to get to this expert level score on these benchmarks.
So essentially you're having it think like we do, which is, like I always tell my kids, don't say the first thing that comes into your head. Think about a few thoughts before you go and say, which I think most people in the world might want to learn how to do that these days. But so let me see if I've got this correct. So you took the large model, you shined a light in a specific area. You, just to be clear, did or did not add any more training data to that?
So in the first version of the model, so in both versions of the model, we did use expert demonstrations and training data. But then the
Okay.
key difference is, did you update the entire model or not, or did you update only a small part of the model? So
No,
in my
yeah,
case,
it's
we updated the
small
entire.
part.
Yeah.
And then you fine-tuned it with clinicians from, I think it was the US, UK, and India.
That's right.
And what kind of judgments did you ask clinicians to make? I mean, how did their input help improve the model?
Shek, do you want to take this one on?
Yeah, I can like explain a bit. So as I mentioned, like previously, we had like this access that we want to make sure that like our model are safe, they provide like non-biased answer and so on and so forth. And the way that we asked clinician was like to provide some like example are basically cases, and we provide some question to them, and they basically write answer to those questions. But like we are asking physicians to be provide that answers that they are like comprehensive. They consider like different aspects that we are caring about, like safety and so on. And when the models seeing those examples, basically trying to imitate the behavior of like a physician and the good answer that we are like expecting. So that's a way that things gonna happen. And we had like 40, I think 40 something, I don't recall the exact number, example from like different clinician at MedPaLM-1, and we expand there.
Okay. And so, I mean, just my background being, you know, in the biological sciences, I'm curious, like, how do you deal with the heterogeneity of the domain? I mean, if you think about an area like finance, where there's more or less a universal language, right? I can go in anywhere and, you know, profit, loss, but it's pretty standard no matter where I go, no matter what company I go into. But in an area like medicine, that if I walk into a different department, different words are used to define, you know, the same thing. And so how do you guys tackle that part?
So I think a lot of it actually we get for free because these models are trained on very large scale internet corpora. And I would say we should not underestimate the power of the internet. There can be ridiculous things in it. And so even if you have something what you think is a very rare condition, it's very likely that someone else would have mentioned about this in some forum on some social media site. And so when you start like, you know, accumulating data that is trawled from all these different sources, it invariably ends up that just contains the information that you need. Whether that's accurate, whether that's fake, I mean, that's, I think, totally different question. But just the scale of the internet means that there is a vast amount of knowledge that's encoded in these models. And so I think that helps us quite a bit. But then when we are doing this expert fine tuning step, I think that over there we're relying on demonstrations, and that's like admittedly from a very small pool of clinicians. And so I think we need more work over there in terms of expanding the pool and also the considerations that we are doing, because, you know, clinicians with different backgrounds, different contexts, different lived experiences, and also the patient context needs to be taken into account and everything. I think I would say that and all is like very early stage. We haven't done much work over there, but the fact that we are building on these internet scale corpora gives us a massive advantage, I would say. It gives us a great start.
Okay, interesting. So this large language model, as opposed to, I mean, even the narrow models are still large. They're not as large as the whole internet, but they're still pretty large. So I'm trying to think, like you're saying, using these huge, maybe that's a better word for it, huge language models, as opposed to something that might be more a larger language model that's narrow in a particular space. You seem to be getting more out of something that's chewed on everything, as opposed to being defined to a specific space.
Yeah, I think that's right. And I think it's more to do with the data that you use to train these models and less about the number of parameters itself for this model. And so there are these laws, like DeepMind has come up with something known as chinchilla optimal laws, which you can use to derive what is the optimal size of a model that you need to train if your data is like these many tokens. And so I think we need to decouple that. But you're right in the sense that what matters over here is the training data itself. And the internet is just so vast and so huge that I think we tend to underestimate what is in there. And so I've been like sometimes really surprised when I interact with these models, both ones at Google and then outside as well, GPT-4, in the sense that like what are like the range of information that is encoded in these models and the kind of things that they're able to do. That is, I think, vastly more than any human that we know of that has ever lived.
Yeah, and there's a few things I wish that weren't in there, but that would probably make it better. But so I'm reflecting on the like Microsoft wrote their BioGPT paper, which was underwhelming, right? Because it really wasn't a BioGPT. It did, 4 things well because they had sort of designed it to do those 4 things well. When I think about MedPaLM-2, is there a specialized task that you've sort of worked on to get it to do, or is it more of a broad-based system? I'm trying to understand the level of depth the system gets to in any particular area, if that makes sense.
Yeah. Shek, do you want to take this one
on? You can go for it. I'm just
Okay.
like thinking that.
Yeah. So as I mentioned before, we are building on top of PaLM and PaLM-2, right? And these models have been shown to be useful in many different natural language generation applications. And so these are not just like typical natural language benchmarks, but also like, generating code or doing mathematical reasoning, even solving like some sort of scientific challenges. And so that base knowledge is already encoded in this model, and we're building on top of it. And then the fine tuning that we are doing is with medical reasoning and medical questions. And so, and there the benchmark that we are fine tuning on, it spans like these exam style questions, these professional medicine questions, but it also includes like questions from PubMed. So that's more like medical research and scientific reasoning questions. And then the final one is consumer medical question answering, like more what a person who would say is looking for medical information. When they go online, what are the kind of questions that they ask, what are the questions that they search, and what is the, and so it depends on the medical information need that they have. So that's what we have fine-tuned on, but I would stress that these models, just because again, they are trained on the internet, they just seem to be generally capable of a lot more tasks than we can even fathom. So think about these models as platforms that can enable many different applications. And so these could involve like retrieval, like encoding knowledge and retrieving them given the right context, might be in the prompt, to like summarization, to like generative tasks in the medical domain, such as like, workflow tasks, generating prior auth letters or like insurance letters or other kinds of stuff, to something that involves medical reasoning that, okay, you should not be using it standalone, but like maybe an aid to a clinician who wants a help from one of these large language models to help with medical diagnosis or just get more information. And finally, this could be directly in the hands of consumers as well. But again, with the right set of guardrails where we can help serve their medical information needs at scale.
Yeah, I mean, I totally agree. Every time I'm, playing with it or read something, I feel like something new has, bubbled to the surface, which is like, oh, damn it, it can do that too. Like, but I always try to distinguish sort of that top level versus the idiosyncratic, like I really need to get to a specific answer. And I find that getting to that specific answer is not always happening with these large language models, that's where I believe like some of these narrow ones that might even, might do a better job. But you started talking about something about how people would use these. And so how do you think these are going to be used or most useful, say, for the medical community? And I'll use that word broadly in the near future and maybe even the distant future, although things are moving so quickly, I don't know what distant future means anymore. If I say 5 years, that's like a lifetime these days. But is it, distilling insights from medical literature, like you said? Is it answering complex medical questions? Is it searching long or unstructured medical texts. I mean, I'm trying to understand, like, what are the sorts of things that you guys envision? And I know at some point you might have to stop the list because it might be too long.
Yeah, I can take this. So I think like for the use case of this model, and especially in the field of like medical domain, we have like two sort of like users. Like one of them are like professionals users, and the other one are like people that consumers basically. Uh, they want to use this like model daily basis. So in my opinion, I think like one way that I can see that like these models can be like really useful for consumers are if we can use these models in countries that they don't have access to medical professional like easily. And if we can like basically add like a multilingual ability to these models could be like very useful. And also like I think in like countries like similar to like North America or like other parts of the world that can be used for patients if we can like provide the answers that they are like really grounded and like safe. They can use it like on daily basis to basically medicate some of the like daily basis need that they have to doctors to basically helping them that if they have a like a worry they can like make a decision to see a doctor or like solve it in a way. But that's I think is going to be like very long from now, and it needs a lot of like safety guards for those use cases. The other part of the word is like a professionals and like for example doctors how they can use like large language model. And you mentioned like a few use cases like already. It can be used like maybe in hospitals for triaging patients, and it could be used to like summarization of like notes, and like even like more you can go up to like I don't know knowledge discovery if you want to like really expand the use cases that is like a large language model they have like for professionals. Vivek, if you want to add anything.
Yeah, I'll maybe just quickly mention a few different points. I think there's a spectrum of use cases, and some of them where the risk is inherently low and you have a human in the loop. I think we are going to see applications of that fairly soon. So these could be stuff like workflow in clinical settings and environments, genetic documentation, which I think is a huge cause of pain and burnout today for the clinician community. And I think LLMs can be a massive step change in improving their overall experience, so that they can actually focus on doing what I think they want to do, which is like interfacing with the patients and providing actual care rather than typing up these documents or whatever. So I think we're going to see very rapid adoption on those fronts, where I think there's still a human in the loop who can verify the answer and then accept it and ensure that everything looks right. But like generating the document itself takes a long period of time. So we can like cut away like several minutes. Say if a task takes like 10 minutes, with these LLMs, we can probably like bring them down to like a minute or two. So that's a big step change, and so I see rapid adoption on that front. The other thing that I would maybe quickly point out is medical education. When GPT-4 came out, and same with MedPaLM as well, we knew that like pretty much every medical school in this country had a grand rounds session talking about use cases of GPT-4 and large language models in medicine. And so we know that every student or every trainee in the country, they're like trying to use GPT-4 to better understand these clinical terms, concepts, and trying to make sense of the data and like using it for charting and learning. And I think that is going to be a big change as well. So you can imagine like a personal medical tutor to all the trainees and people who are in medical school today. And that's, I think, again, going to be a pretty big experience and change. And it's going to up level like pretty much all the doctors that are going to come out, because harness the right way with like an intelligent person in the loop, I think these models are going to be very useful, and see medical education improving significantly as well. But I would say that again, like this is again my personal opinion, but for a lot of us in the team building out MedPaLM-2, we care a lot about access to healthcare. Like I personally grew up in India, where for many people in the nearby towns and villages, going to see a doctor would mean like walking 30 miles in extreme heat, giving up on a day's wages, that was simply like unpalatable to like most people. And so
Right.
many people go their entire lifetimes without seeing a doctor, and that meant like adverse health events accumulated over a period, and then like lower life expectancy and everything. So with these systems, with these models powering like systems, you can imagine like a pocket GP, a world-class pocket GP, and we can like put them like directly in the pockets of billions of people worldwide. So that's the North Star goal, but that I think will take a lot of work, like a lot of rigorous validation studies, and we don't have the answers to how to do validation of these systems just yet, just because of the broad range of capabilities over here. So I think a lot of things need to fall into place, but simply the fact that we can even think about that future, I think that itself is immensely exciting. Honestly,
oh,
I
no,
didn't.
this is
Yeah.
hugely exciting. I mean, when I talk to people about everything that's going on in the space, I'd say for the past like 5 years, most people that I talk to they're not even close to being in tune with where things are and with these advances. I mean, something simple like having the system prepare the physician for communicating with a patient the right way, right? That it can role play that way, I think is, very cool. It's a little scary, but very cool, right? But Shek, you mentioned something earlier and you said it again just a few minutes ago. The guarding against potential problems, right? And I've seen this in other LLMs, and then if you work a little bit, you can actually break them, right, and get them to say some very interesting things. How do you manage incorrect answers or harmful answers, or you said answers that don't reflect scientific consensus, right? Hallucinating, um, bias in the model. I'm struggling with, is there truly a technical solution to this? Because I think once you train the base model, it's sort of, these things are so big. How do you adjust to get them not to do something?
Yeah, to answer to your question, I think it's like a very good question actually. Um, it has like two parts. Like one part is that like the LLM research is like ongoing research, and we were gonna see like more and more um, like breakthroughs coming out because like we need those like type of like grounding and like safety net, not in medical domain, even like for daily uses. And there's a lot of like research around like the safety of these models and like how to prevent like basically hallucinations or like providing like harmful answers and so on and so forth. So there is a lot of like research happening there. Like one way that like people like approaching is human feedback, that they're basically collecting human feedback and like feeding that feedback to the loop of like training the models, so they can like a bit like avoiding this. Uh, that's like one part. Even for, I think for medical purpose also, that could be like very useful, and it's gonna like help us to ground these like models and like provide some safety of them. But I think the type of like feedback that we have for medical purpose is going to be like way different than the like general use cases. Like if you like interact with some of these chatbots that they're like out there, you can see that like you have like thumbs up, thumbs down, and you're going to say that, okay, I like this answer, I don't like this answer. But like for medical purpose, it's not like this. The range of like human feedback that you need is like way broader. You need to have like feedback on the safety of these models. You need to have feedback on the basically medical concepts of these models, and like if the answer that they are providing is like aligned with the like a medical knowledge that is like out there. We know that like medical knowledge and like recommendations are changing from one country to another country, or like even like in different states, you can have like different type of like recommendation if these models are like providing them. And also like bias. The other way to also like control these models and like train them is like through adversarial like testing. You need to test these models like for different kind of attacks that they can like come to them, and like different like outlier question that you didn't like expect, but they can like cause harm. So that's happening. And like when you're like putting back those questions inside your training loop, you're gonna like enforce these models to provide the answers that you're like more grounded. But I also do believe that at this point, there are a lot of things that we don't know also. And we should like admit that there's a lot we don't know, and we don't know how to control them. But I think as we have a lot of like bad actors that maybe use these models in a harmful way, we also have a lot of like knowledgeable like researchers that they are trying to basically ground these models and like make them safe. So let's see what's coming up like next few months, I guess. Months is the scale of things that we are talking about right now.
Yeah, I mean, I think, you know, like I said, I mean, just trying to keep up with the literature is almost, I don't want to say it's impossible, but it's incredibly challenging. Can you guys talk a little bit about this? I think it's multi-med QA. This is your, I believe, a benchmarking system you guys introduced for LLMs in the medical domain, right? So I don't know, you know, what kinds of standards or questions go into multi-med QA? How are you guys sharing or spreading this new benchmark? I'm assuming you're letting other groups use it. Just if you can talk about it a little bit, that would be great.
Shek, do you want to take this one?
Yeah, I can like talk about that. So multi-med QA is basically a benchmark that we put together. Is like 7 different kind of like data set that they have long form answer, short form answers. Some of the form of the questions that we have is like open-ended. So it means that they aren't like yes, no, or like multiple choices. We also have like multiple choices question such as like USML inside that. These data sets, a big chunk of it is like right now open source, like they're out there. The thing that we did was like we put them together in like a format that is like accessible and like make it a benchmark. One like nice addition that we had to those previous data set that has been out there was the consumer questions and health search QA basically. And those questions are the question that consumers like asking search engines. So the medical question that they have, like medical concern that they have, and we have like around like 3K questions. And like we are gonna release those questions along with the MedPaLM paper when it's published. And you can just like wait for that. And we are waiting for other people to use this benchmark as we are doing it.
Okay. And so what are the next steps in the rollout of MedPaLM-2? I mean, is it, I'm assuming certain Google Cloud customers are going to gain access to MedPaLM-2 first. I mean, how are you guys thinking about that program? What kind of feedback are you hoping to get from your partners? And, you know, I'm assuming you're going to use that to improve the model. And I guess, when does the average person, you know, do they get access to MedPaLM-2 to play with? And, you know, when might that happen?
Yeah, I can take this one on. So yeah, as you mentioned, we have been piloting this trusted tested program with some very large and established companies out there, providers, pharma companies, payers across the healthcare and licenses spectrum. What we are hoping to get out of that is feedback as to like what are the use cases that they envision, because as I mentioned, like language models are a platform technology, and in the hands of different people, it could mean very different things and different set of use cases. And so we want to understand what are the use cases that people want to are thinking about with these language models, and also maybe the value associated with them. And then the second thing is how well are the models today performing. And so once we get a good sense of that, then we can prioritize how to improve, the model alongside on some of these specific use cases, and also use that feedback data to generally improve these models, make them more safer, and simply just better at like reasoning and solving tasks and questions and so on and so forth. But then we also have a few applications and use cases in mind. And so, like Google is a search company, and it has like various apps, various surfaces with billions of users. And so you can imagine this model being surfaced in the future along one of these surfaces. We don't know. This is my personal opinion again, that like I think models such as MedPalm, until we are very certain about the validation and the safety, we are probably not going to like very immediately release it and put it in the hands of general people. But then like we're very open to like research partnerships, and also the trusted tester program is just going to expand. And so if you're a big company with well-defined use cases, or even if you just want to explore, then the trusted tester program is a great opportunity. And then if you're thinking about research on MedPalm, we're very open to collaboration and opening up the model to like explore specific use cases in academic clinical workflow settings. But then, yeah, I don't see a future, say even in 3 months, where this model is just going to be opened up and like, we put out a UI where people, like anyone can interact with this model. I think that's going to be, it's just not safe yet. And we want to do this. We want to do this well, definitely, and we want to move as fast as possible given how the field is moving. But we also want to do this safely, because I think if we do this safe, then I think we will have the impact that we want in a reasonable time frame.
Yeah, I mean, the in one way, right, the race is on and it's scary, but it's still like the race is on. So I mean, it's everybody's running at 100 miles an hour.
Yeah, bold and responsible.
But you don't know. I'm on board for responsibility, right? But I think in one of the videos you mentioned that you wanted to make the model multimodal, and so maybe you could explain that a little bit more. I mean, what do you mean by that? What new scenarios or capabilities might be possible? Will doctors and nurses be able to upload a medical record, a medical image, genomic data? I think those are some of the things you mentioned in the video.
Yeah. So I think if you look at medicine as an endeavor, right, I think it is a multimodal endeavor. There's like so many different modalities in there that characterize a given individual. That includes medical records, but also images, labs, genomics data, protein sequences, everything. And so in order to like really do well in medicine and be able to like understand a particular individual so that you can solve those tasks better, you need to be able to like integrate data from multiple different modalities. That's what our clinicians do. I mean, they don't like just look at a piece of data they have all the context about everything else that's happened. So even when a radiologist, they know so much other information about other things, and so they're just not looking at the image that is in front of them on the screen and vacuum. They have all the other context. And so we want to give our models that capability as well to be able to like integrate that data. And so individually, this is going to enable a lot of different new applications. But I think fundamentally what's going to happen is it's going to like, as these models just become more generally capable about like interpreting and integrating data at scale, it's just going to open up a new set of applications in the setting of like providing care, and so you can imagine doing things better that we were trying to do previously, like medical imaging, for example. So previously we had models, and a lot of these models are getting through regulatory approvals. But the thing is, these are all narrow domain models that produce like probability estimates for the presence or absence of a given disease or something like that. You can imagine the new class of models with like ability to like express and interact and collaborate, being able to have like a conversation about a given case with a clinician. And that you can imagine the power of such a system that's going to enable so much better human AI collaboration. So like imagine a radiologist talking to an AI and then them collaboratively solving a difficult case, or like a general practitioner talking to an AI, learning more about this medical image because they want to understand in depth what's happening. I don't know who exactly said this, but like, I mean, we talk about like reports a lot in the medical setting, but the goal of the medical report itself is to enable a conversation. And unfortunately, because of how the entire ecosystem is today, those conversations don't happen. But I think with AI, with these multimodal AI that can interact and express itself, I think can enable those conversations to happen more. And I think that is in turn going to enable, just enable our doctors to provide better care to people. And then the second thing I would say is, as you start integrating information at scale, that is going to also fundamentally enable like new knowledge discovery in the biomedical domain, because you're going to see all sorts of new information that you did not necessarily put together before. But these models, just because of their ability to like process data and so much rich multimodal data that no human can ever do, are going to be able to like, shine light on new phenomenon. And that is going to improve our understanding of diseases, maybe enable the discovery of like new therapeutics and discovery mechanisms and so on and so forth. So I think as we go into multimodal, the kind of things that we're going to be able to do is just richly and like, incredibly exciting.
Yeah, I mean, people wonder like why I tell people I wouldn't want to work in any other space. This is like, so much fun on a daily basis, right? You're not only getting to work on cool stuff, but you're actually improving the human condition, right? And so I totally agree with you. Although I think a few doctors who are listening think that the computer is actually going to talk back to them. That's going to freak them out. Shek, I cut you off. I thought you were going to say something. I'm sorry.
No. The explanation that like Vivek gave, I think that could be like a vision that we could have like for a few years from now. It's like a really sweet vision, and like let's see how things gonna move.
Yeah, it might not even take a few years at the way things are going. But
yeah.
Before I let you go, so you guys are like deep in the space. You're actually working on these systems. You're getting them to work. I'm sure you guys have your moments of going, oh, I didn't realize I could do that. Because if I'm having it, I'm sure you guys are having it, except you're having it sooner than I'm having it. But why are these LLMs so good? I don't want to say, I hate using the word good, but why is it so much better or so good at, say, medical question answering and so many other different areas that you keep poking at it and it seems to do a pretty decent job. And then sometimes you ask it and it does something you didn't expect it to be able to do because it was never told to do that particular function. Can you guys speculate on that? I mean, maybe you know the answer and you could share it with all the rest of us.
Shek, why don't you go first and then follow?
Yeah, I think that's coming like mostly like the thing that you're saying is like mostly like hallucination, or like they're combining things and like producing new stuff out of that. And that's like usually depending on the underlying parameter that you use for these models. And I think that's naturally coming from the way that these models gonna get trained, which is like prediction of next words. If you want to like make it like really simple, so you can see a word that they can like combine things to produce new stuff as an export. So that's a place that they usually all of this like new combination that you didn't expect coming from. That's my idea, but I'm not sure that like if Vivek wants to add more.
Yeah, I think there are, at least to me, there are two parts to this question. I mean, I think we can explain some of what we are seeing through scale and the next word prediction objective that we are using these models on internet scale data, combined with like sufficient depth of the model, which enables intelligent compression. And that in turn leads to like the emergence of reasoning algorithms and the kind of things that we are seeing these models capable of doing. The second thing I would say is, I mean, this is also a very different form of intelligence to what we are used to encountering in humans. And in many ways, it's complementary. In some ways, it's not. And so that's where I think the friction is generally. But then what is happening is AI is this very unique field where we are building something and then we are studying it. I mean, it's not like physics or chemistry or biology where the thing already exists in nature and then we are like, trying to like shine light like a torch on it and trying to study and understand it better. I mean, all that is happening at the same time. So I would say that, I mean, yeah, there are some things that we understand as to how these models are able to do certain things based on how we train today, as Shek mentioned. But I would also say that there are a lot of things we don't understand over here, especially the scale of these models makes it, I think, incredibly tricky. And I don't know, who knows, maybe it's going to take an AI to help us shine light on what's happening under the hood over here. Maybe us humans are not capable. But no, jokes aside, I think there's a lot more work that needs to happen under the on the interpretability front.
No, I agree. I mean, this thing is moving so quickly, and it's funny because people say things like, how do I know it made the right decision? I'm like, how do you know that doctor made the right decision? I mean, it's so interesting, right? That we expect the machine to be 100%. But if you barely passed medical school, last time I checked, you're still called a doctor. So it's been great having you guys on the show. Did I miss anything in our discussion that you guys want to highlight?
No, I thought this was great. I mean, I really enjoyed this conversation. The set of questions that you asked was fantastic.
Yeah. Thanks for having us. We enjoyed it.
No, it was great having you, and maybe we'll have you. I'm sure there'll be MedPaLM-3, and then fantastic, or maybe the multimodal MedPaLM, and then have you back on the show. It just seems like it's a never-ending process. I'm sure that you guys have like beds under your desk because there's no reason to ever go home.
No, it's fun. It's an honor and privilege, and I think we have to just respect the opportunity that is in front of us. And so hopefully we can do something big and good over here.
Excellent. I can only wish you guys incredible success.
Thank you so much.
Thank you so much, Harry. Thank you, Shek.
Thank you. Thank you.